All right, problem number 2 of day 2 of section 4.6 asks us to determine whether the functions below are invertible. If so, find a formula for the inverse function. If not, find two inputs which give the same output. Okay, so I'm going to go on to a new page for this. So part 1, or I guess part A. Oh no. Okay, part A. The function is a of x equals negative 4x minus plus 1. Okay. So how do we find a inverse of x? So I'm going to follow the steps that I talked about in the previous video. So step 1 was to write y is equal to negative 4x plus 1. The second step was to swap x and y. When I do that, I get x equals negative 4y plus 1. And then I want to solve for y in x equals negative 4y plus 1. So this is the part of the problem that will take the longest, probably. So, no, I'm trying to draw an arrow. It's not working. Okay, so let's do that. So I'll have x equals negative 4y plus 1. If I'm solving for y, I can subtract 1 from both sides. So I get x minus 1 is equal to negative 4y. And then, to solve for y, I can divide both sides by negative 4. To get x minus 1 over negative 4 is equal to y. So that a inverse of x is equal to x minus 1 over negative 4. Okay, so is this a function? The answer to that question is yes. So this is a function, so it is indeed a inverse of x. Okay, so on to part B. So part B gives us that b of x is equal to 1 over x. I'm going to go through the steps again. So I'll write y is equal to 1 over x. Then I'm going to swap x and y to get that x is equal to 1 over y. And then I'm going to solve for y in x equals 1 over y. Okay. So I'm going to move this up here just like before. Let's solve for y in x equals 1 over y. There's only so many things we can do here. So maybe what you might try to do is multiply both sides by y. To get xy is equal to 1. And then to solve for y, I just need to divide both sides by x, so that y is equal to 1 over x. Okay, so is this a function? Yes, this is a function. So we have that b inverse of x is 1 over x. So that's a little bit strange, right? Because b of x was equal to 1 over x. But this is saying that b inverse of x is equal to 1 over x. So that's a little weird. That weirds me out. Maybe I might want to check that. I want to go through an example of checking our answer. We can do that by composing b of x and b inverse of x, or what we think is b inverse of x. So b of b inverse of x is going to be 1 over b inverse of x, which is 1 over x. And we can see that this is going to be the same thing as b inverse of b of x. Okay, so 1 divided by 1 over x. Well, I can write 1 over x as x to the negative 1. Using exponent rules, I can simplify this to just x. So this tells me that 1 over x is its own inverse. So that's pretty cool, right? Maybe? What is happening? Yeah, I think that's pretty cool. So let's go on to part C. Part C gives us that c of x is equal to the square root of x squared plus 3. Okay, so I can tell you right away that this is not going to be invertible, because so notice that because I've got an x squared in there, if I do like c of 2, I get the square root of 4 plus 3, which is the square root of 7. And if I try c of negative 2, I get the square root of 4 plus 3, which is the square root of 7. So when I try to invert these, the inverse would have to send the square root of 7 to both 2 and negative 2, which wouldn't give us a function. Okay. So if you try to go through this with our step-by-step guide that we were going through before, you might get something that you think is a function, and you probably will. But the important thing is that I need to make sure that so for a function to be invertible, or to have an inverse, each input must have a unique output. This makes it so that when I switch the input and output, I get something that's a function. Okay, so c of x does not have an inverse. And all we needed to show to see that it doesn't have an inverse is two inputs that give us the same output. So in this case, 2 and -2 gave us the same output of square root of 7. So the final part, part D, gives us that d of x is equal to 2x plus 1 over x. So from what I can tell, this looks like it should be invertible. I don't have like an x squared or an x to the 4th or something. So let's try our step-by-step thing. So first we're going to write this as y equals 2x plus 1 over x. I'm going to swap x and y. And then solve for y. Okay, so I am solving for y in x equals 2y plus 1 over y. Okay, so I want to say that, first of all, every time I've taught this class, this is always, for some reason, a tricky problem. Maybe because it requires more steps than you might be used to. So let's try to solve for y. You'll absolutely see this on an exam, so please pay attention. So we'll try to solve for y. The only thing I can see to do right now is to multiply both sides by y. That'll get y out of the denominator on the right side. So we get x times y is equal to 2y plus 1. Okay, so now I've got y's on both sides of the equation. What I'm going to do is move all of the y's to the same side. So by that I mean I'm going to subtract 2y from both sides to get xy minus 2y equals 1. So far, this doesn't look like we're solving for y, but notice that xy and 2y have a common factor of y, so I can factor y out. So I get y times x minus 2 is equal to 1. To solve for y, I'll divide both sides by x minus 2. So y is equal to 1 over x minus 2. So that d inverse of x is 1 over, let me write this, and then we'll be done with this problem, 1 over x minus 2. And that's our answer for the inverse.